So what we're going to do in actually this mini lecture plus two others is work with these three sets of data that you see on the screen. The first thing that we'll do is conduct a one sample difference of means test using this data. And then in the next mini lecture, we'll do a two sample difference of means test using this data. And then the third mini lecture will involve another two sample difference of means test using this data. And what you'll see across these three mini lectures is that this is actually the same set of data, just used in different ways. So for right now, let's focus on this set of data right here. And what we have here is a situation that we actually talked about in class. The research question, as you can see at the bottom of the screen, is do college students drink about 120 ounces of soft drink per week? Soft drink manufacturers might be very interested in how much beverage students drink. So we collected data from 20 students, and this column subject number just represents each of the 20 students in our sample. We also collected data on each student's gender, with the number 1 representing females and the number 2 representing males. The third column of data is how much beverage each of the students indicated that they consumed per week. So for student number 1 as an example, it's a female, because 1 equals female. It's a female, and she indicated that she drinks about 110 ounces of soft drinks per week. Student number 9 is also a female. She indicated that she drinks 50 ounces of soft drinks per week. Student number 13 is a male because of the number 2 in the gender column, and he only drinks 10 ounces of soft drinks per week. So while we have data here on both gender and the amount of soft drinks that the students consume each week, in this particular exercise, we're going to ignore the gender data, and we're only going to focus on the amount of beverage consumed. And you can see here down in the descriptive statistics, across the 20 students, they drank on average 123.5 ounces of soft drinks per week. You can also see here, standard deviation is 111.71. You may not realize that, but for a mean of 123.5, that's actually a large standard deviation. So again, our research question is, do students drink about 120 ounces of soft drinks per week? And our observed mean, our point estimate, if you will, is 123.5 ounces. So we want to compare one observed average, 123.5, to our hypothesized value of 120. So we're going to do the one sample difference of means test. So what we would do there is, to run this in Megastat, we first go to add-ins and click on add-ins. And then we go over to Megastat and we click on Megastat. And then we drag down to hypothesis tests. Recall that we're going to compare one observed mean, our point estimate of 123.5, to an hypothesized value of 120 ounces of soft drinks per week. So we click there. And we get our data box, and it first asks for our input range. Notice what I'm going to do here is I'm going to highlight the column with all of the amount of beverage drunk per week. And I also, if you'll notice, I also highlighted the column header, amount consumed per week. The hypothesized mean, if you'll recall, is 120 ounces per week. Because of our small sample size, we will do a t-test. 95% confidence interval, again, we always stick with 95 unless I indicate otherwise. And a 95% confidence interval means that there's a 5% probability that we could make a type 1 error. I'm going to ask for the confidence intervals. And then we had no reason to know whether college students might drink more than 120 ounces or less than 120 ounces of soft drinks per week. So we set our alternative up in the two-tail format. So our alternative is not equal. So we're now ready to actually run the megastat process. And here you see our results. Let me try to make it just a little bit bigger so that it's easier to see. Here you'll see that our hypothesized value is 120 and our point estimate is indicated as 123.5 ounces per week. Okay? You'll see here that our observed t-value is 0.14 and our observed p-value is 0.89. Now, as I've indicated to you previously, megastat gives us the observed t-value, but it does not give us the critical t-value. So we have to look that up ourselves. So for a two-tailed test with 19 degrees of freedom, the critical t-value is 2.093. So let me just type that here. 2.093 is our critical t-value. And remember the rule that when the observed t, in this instance 0.14, is less than the critical t of 2.093, when our observed t is less than our critical t, we fail to reject the null hypothesis. ORIS provides us the observed p-value. In this instance, it's calculated at 0.89. You'll recall that our critical p-value is 0.05. And the rule is when our observed p-value is greater than our critical p-value, we fail to reject the null hypothesis. So you'll see here that we draw the same conclusion whether we work with the t or whether we work with the p. When our observed t is less than our critical p, we fail to reject the null hypothesis. When our observed p is greater than our critical p, we fail to reject the null hypothesis. So here we reject the null hypothesis and we conclude that students drink about 120 ounces per week. 123.5 is not different enough from 120 to conclude otherwise. Now, typically in statistics, we say, okay, we failed to reject the null hypothesis and we feel good about ourselves and we go on to the next problem. One thing that I want to do with you students in MS 264, though, is move you from mere statistical interpretation to being able to provide managerial insight. And that's why this part of the output is so critical. If you will recall, in Chapter 7 we learned about the point estimate. In this instance, the point estimate for this exercise is 120. And then in Chapter 8 we learned about the margin of error as well as the confidence interval and the interval estimate. And that's what this part of the output here provides. Now, I expect you to have a decent idea of how to calculate the margin of error, but we're fortunate that megastat calculates that for us. I also expect you to understand how each of these values is determined, the 71.27 and the 175. The lower bound, if you will recall, is equal to the hypothesized value minus the margin of error. So the observed value, 123.5, which is our point estimate. So 123.5 minus our margin of error, 52.28, that's how we get the 71.21 value. And then our upper bound is the point estimate of 123.5 plus our margin of error calculation of 52.28. That's equal to 175.78. So calculating the margin of error is no big deal computationally. It's just that megastat does that for us. Calculating the lower bound and the upper bound is no big deal. That's just a matter of simple subtraction and addition. However, the managerial interpretation here is what's really key, okay? Because while failing to reject the null hypothesis leads us to conclude that the true population mean is about 120, what this really tells us is that our 95% confidence interval ranges from a low of 71 to a high of 175, almost 176. So what our 95% confidence interval tells us is while our point estimate is 120 ounces, while our point estimate is 120 ounces, we're 95% confident that the true population mean ranges somewhere between 71 ounces and 175 ounces. In other words, our confidence interval is more than 100 ounces. So again, I want to emphasize the point here that failing to reject the null hypothesis is informative. But understanding that because of our small data, sample size of 20, and because of our large standard deviation, we're left with a very wide confidence interval ranging from a low of 71 to a high of 175. I expect you to get good at conducting the one sample difference of means test. But I also expect you to make that transition from knowing whether to reject or fail to reject the null hypothesis, which is statistically relevant, to being able to work with this portion of the output to provide managerial insight. Our confidence interval is as wide as the Mississippi River. Our confidence interval here is 100 ounces wide. We're 95% confident that while our point estimate is 123.5 ounces, while our point estimate is 123.5 ounces, our lower and upper bounds range from a low of 71 to a high of almost 176 ounces.